Hello and welcome to today's webinar, Tips for Induction Sealing Liquids for Safe Shipping with Amazon, FedEx, and UPS. This is Mark Plantier of Enercon Industries, and we're very pleased to bring you this informative webinar on best practices for preparing liquids for shipping. Please note that this webinar is being recorded and will be made available to all registrants as soon as it is posted online. You may ask a question at any time during the webinar by typing it into the question tool provided on your screen. Our panelists will answer questions at the end of the webinar. If there's not time to answer all of the questions during the webinar, our panelists will follow up with you after the webinar. Topics that will be covered today include packaging guidelines from Amazon, FedEx, and UPS, how to select the right liner for your application, induction sealing absolutes, how to set up an operating window for successful sealing, and additional considerations when shipping through alternate channels. We're fortunate today to have two extremely knowledgeable professionals in the area of induction cap sealing applications. B.J. Reddick is Regional Sales Manager for Sealig and has been part of the packaging industry for over 25 years. He is an active member of the Institute of Packaging Professionals and is regarded as a technical expert in the field of induction liners. Ryan Schilke is Enercon's Vice President of Sales and has been involved with the packaging industry for nearly 20 years. Ryan is a member of PMMI's Global Marketing Committee and a former board member of the Association of Sauces and Dressings. Both Enercon and Sealig work on many projects together, and recently they earned recognition from the Association of Sauces and Dressings for their contributions to the association's 2015 Package of the Year, produced by Unilever. I'll now pass it over to Ryan to talk a little bit about Enercon.
Thanks, Mark. Enercon is a company based in Milwaukee, Wisconsin, with a strong global presence. As you can see on the map, we've got a presence on every continent across the globe. We have manufacturing and sales facilities in the United States, both in Menomonee Falls and Germantown, Wisconsin. Sales and service facilities just outside of London, which help us cover the continent of Europe. And our most recent facilities just outside of Bangalore, India, which help us with the Asia market. We manufacture induction sealing equipment that can run the gamut from low-speed manual applications all the way up to the highest speed production applications.
Hi, this is BJ. Thanks, Ryan. So just to give you a brief overview of the Sealig Group, our primary division is the liner division, or cap liner material. We supply a focus in induction inner seals. We also have a flexible division based out of Switzerland. The Swiss operation supplies high graphic films for the candy industry, cheese industry, and cookies. The technical division provides highly engineered technical laminations for barrier requirements, materials that are used for defense, medical applications, things like hazmat suits. The markets that we serve essentially are the food and beverage industries, dry powder contents, pharma, nutraceuticals. We do a lot in the cosmetic markets, various chemical industries. Essentially, any rigid container with a seal or a closure would be a market that we serve. Under the Sealig Group, we have 4 manufacturing facilities, one in central Illinois, one outside of Toronto, Canada, one in the UK, and one in Switzerland, with distribution all over the world. This is just a brief snapshot of some of the major national brands that rely on Sealig to seal their products. So I'll pass it back to Mark to go over the guidelines for shipping.
So today's webinar topic was developed based on the numerous calls both Enercon and Sealig received from packagers looking to expand their products through new distribution channels. In many cases, these packagers have been told they are required to seal their products, but are not sure where to begin. We'll begin by looking at some of the insights companies like UPS, FedEx, and Amazon provide prospective users on their services. Please note that this webinar is designed to provide you with valuable information, but every packager should specifically consult with their prospective carrier or channel partner. The first source that we'll cite comes from Amazon's website. It reminds us that during shipping or when in inventory, a leaking product not only compromises itself, it will also cause damage to other products and be a hazard to employees. UPS specifically calls out that a heat induction seal should be used. They also show a bit of their application knowledge as it reminds the packagers the importance of application torque of their caps. This is something Ryan will be covering in more detail later. FedEx, meanwhile, refers to an inner seal and a perforated breakaway cap. This is essentially a double seal. Amazon defines a double seal as the combination of a tightened lid and either a safety seal, which would be either an induction seal or a seal on the outside of the neck of the bottle. As you can see in the pictures, the ketchup bottle has an induction seal. The Fiji bottle shows a tightened lid, while the honey product shows a tamper-evident band. While both the band and induction seal might meet the criteria by the definition, the induction seal actually prevents leaks, whereas if the cap becomes cracked or fails in any way, it's unlikely that a tamper-evident band can contain the leak. Amazon has a nice video available online which covers many of these basics, as well as their 5-step 3-foot drop test. Induction seals have a successful history of passing these drop tests. One final note, Amazon does decree that any liquid product more than 16 ounces additionally requires bagging. Before we pass the presentation back to BJ, who will cover the reasons why induction sealing is a preferred method, we wanted to point out a distinction that a pressure-sensitive liner does not offer the same performance features as an induction seal. You'll recall Amazon specifically referred to or UPS referred to a heat induction seal, and Amazon referred to the type of seal you would see on a ketchup bottle. These are not pressure-sensitive liners. Only an induction liner creates a hermetic seal, and in fact, pressure-sensitive liners are not recommended for use with liquids. With that, we'll turn it over to BJ Raddick of Sealig, who will dive deeper into the benefits of induction sealing and key concepts related to selecting the right induction liner for your application.
Thanks, Mark. So the focus really is the safe transportation of liquids through the distribution channels. If you move over to option number 2, which is the shrink-wrapped option with putting the package in a poly bag, you know, it's very difficult to access the product because you have to remove the container from the poly bag. It has an inferior presentation. It's not really the way the brand owner designed the package to be displayed or to be shipped. Incidentally, the poly bag itself must have a suffocation warning printed on the bag, which is also certainly a negative. It also doesn't prevent leaking. It does contain the leak should the product leak in the poly bag, and tamper evident only if the shrink sleeve indicates it on the neck of the container. And the drop test may still result in leaking into the poly bag. If you move over to option number 1 with the induction seal package, we believe it to be a consumer-friendly version. Brand owners would have that as their intended presentation, again, not having the poly bag. It protects the primary package and others in shipment, preventing the leaking. It can also be provided in a tamper-evident version if required. Also has a very successful history of passing drop tests and is also resistant to pressure and vacuum as products are either shipped over the Rocky Mountains or shipped via the airlines. The induction seals don't only prevent leaking, but they have other benefits, of course. The First Brands was the first company to use induction sealing to address leaking for their Prestone antifreeze. The Department of Transportation is finding First Brands because of the Prestone that was leaking, and so they met with the 3M Corporation to develop the first induction seal. So the first induction seal was developed specifically to address the leaking issues. But certainly they also provide a level of consumer confidence. For the pharmaceutical industry, they provide tamper evidence. They can extend the shelf life of the product, provide a sense of safety and security. They can maintain the efficacy of the product itself, seal in factory freshness, and prevent contamination, retain aroma, and prevent product pilferage. So let's go through the logical questions in order to select the optimum material for a specific application. First off, we've got the standard one-piece, or sometimes called a single element liner, that's comprised of a backing, typically a board or a foam, the aluminum foil, an optional PET barrier layer, and the heat seal film. The backing is essentially bonded permanently to the foil structure and with an adhesive so that the entire material welds and seals to the container. Obviously, as a heat induction material, it prevents leaking. It helps address any defects in the bottle finish, step at the parting line, flash, or excess trim. As the heat induction process, it will melt the heat seal film, and you get a little bit of lip melt so that you form a good bond. It can help address some of those poor quality issues with the finish. And also, if the closure does back off during shipment, because it is hermetically sealed, it will not leak. So for liquid applications, really the single element material would be best for one-time or single-serve applications where reseal of the closure is not a functional requirement, and the cap itself will provide an adequate seal. And also products that might not be stored on its side, but rather stored upright after the induction seal is removed. So kind of the opposite of a one-piece or single element would be a two-piece or separating induction seal. Here we've got a backing, typically pulp, a temporary bond, typically wax, then the foil and heat seal film combination. In this case, during the induction sealing process, that temporary bond is melted, it is absorbed into the backing, and you achieve separation. So that that backing that stays in the cap is there to provide reseal post-opening or after the induction seal is removed. Again, similar to the one-piece liners, the two-piece will address the defects in the bottle finish, and if the closure does back off, it'll prevent the leaking from occurring. And for liquid applications, it would typically be used for multi-use, where the package stays on the shelf for a period of time, and also if the backing helps provide reseal, again, after the material is removed. So the container resin is one of the questions we would typically ask. If it's polyethylene, polypropylene, PET, PVC, or polystyrene, that will essentially help us narrow down and select the best heat seal film for the application. And the next question would be the product that's being contained. Obviously, if it's a wet product itself, we would typically want a foam backing that's impervious to moisture, or perhaps apply a PET film on a board, again, to prevent the board from absorbing moisture. And then if there are aggressive elements that could possibly be corrosive, we would include a protective barrier layer to protect against the delamination or possible corrosion. So the next question would be the filling method. If it's a hot fill, retort, aseptically filled, is it a flood fill or a cold fill application? This will help us narrow down and specifically select the best backing for the application. For example, for some hot fill filling lines, you might need a thicker backing to provide insulating characteristics for that hot fill. And you also may need a barrier layer to protect the heat seal film from corrosion in the event of a hot fill or similar application. So for the seal selection process, we look at the removal characteristics. Typically, the peelable or clean peel structures are used in the food and beverage industries, where upon removal, there's no residue left on the container lip. For peelable tamper-evident materials, the residue, typically a film or foil or sometimes paper, is left on the container to provide that tamper indication for the consumer. Or are you looking for a true weld that's easy to entry? Typically, you'd be able to breach that membrane with your finger, commonly used for the pharmaceutical industry or nutraceutical industry. Or perhaps for some chemicals or aggressive products, you need a true weld that's difficult to breach. You might need to use a kitchen utensil like a knife or a screwdriver to breach the membrane. So for tabs are obviously becoming very common, have been for a number of years for consumer convenience. There are a number of different tab designs out there, from the traditional tri-tab. I've seen as many as up to 8 different tab on the edges of the material for the consumer to grab. The half moon tab concept, which is the lift and peel as the half moon tab or the top tab for 2-piece, obviously provides a premium experience for the consumer, can provide some customer loyalty. It also avoids product contact surface. As you remove the material, your skin doesn't come in contact with the product at all. And then for functionality, breathable vented membranes are also commonly used. Some products require equalization of the pressure as materials or products are shipped over the Rocky Mountains, as I said before. Products that might off-gas, or products that you might want to have an aroma or fragrance interaction as the consumer removes the closure. And I'll pass it to Ryan to go over the PHT.
Thanks, BJ. Now that we know a bit about some of the basics around selecting materials, the bottles that you're going to use, the functionality of an induction seal that's going to help you prevent leaks as you're shipping materials, let's talk a little bit about the basics of induction sealing and how you can ensure you achieve a perfect seal every time. So with any process in which you're trying to seal a product, you're going to have 3 elements that you're going to think about: pressure, heat, and time. So the first one of those, pressure, in an induction sealing application is achieved with cap application torque. You'll see that in the image here is the arrows pointing down, and what we're really looking to do is to provide adequate torque or adequate downward pressure of the closure onto the liner, ultimately to the land of the container. Inadequate torque is probably the biggest cause for failures of induction sealing during the process. One rule of thumb that you can use, and I'd always recommend that you consult with your closure manufacturer on this, is a rule of thumb that you'll need half the diameter of the closure in inch-pounds for application torque. So say you've got a 38-millimeter closure, you're going to need to provide somewhere around, 18, 19, 20 inch-pounds of torque, and provide that consistently. Consistency is the biggest component that we're going to talk about and that you're going to see in your induction sealing application when it comes to cap application torque. Second component is heat. With the induction sealing process, the lines that you see on this screen is the electromagnetic field that is emanated from the sealing machine, and that is what applies the heat. That field is going to induce a current into the liner, and as BJ mentioned, we melt the heat seal material on the bottom of the aluminum foil, which causes that bond to the container. Finally, that pressure is going to be applied via cap application torque. The heat is going to be applied by the induction sealing machine, and we need to apply that for a certain amount of time. With most cap seal applications, that's going to be dictated by the line speed of your conveyor. How many bottles per minute are you running? How many feet per minute or meters per minute is your conveyor running? And that is usually a constant that we'll take into consideration that we need to know when looking to find the right induction sealer for you. you'll accommodate for that time by varying the output power of the sealer accordingly to your application. Typically on high-speed lines, you're going to look to increase the sealing energy or have a more powerful unit. Lower line speeds, you're typically going to decrease or need a less powerful unit. That relationship is not linear, so it is a component that if you increase the line speed, you may have to, if that line speed increases by 10%, the increase in sealing power is not always an equal 10%. It may happen to be that, but is not always the case. And we'll get into this in a bit more detail as we start talking about finding your sealing window. So establishing that cap seal operating window, as we call it, is on a continuum, and we'll dive into the details now about how you're going to find that range that provides a good seal on your application. So we talked about cap application torque. Again, it's going to be the key process in that. We've had many applications where we'll come with a customer of ours who says, hey, we're getting really good seals on 87% of our seals, but 12%, 13%, we aren't getting good seals. You dive into that and say, boy, that's a pretty big failure rate. We are many times well under 1% failure rate, and it comes down to that cap application torque. Maybe a one head of an 8-headed capper isn't providing applications torque. So that consistency is key. We're going to talk about centering the container as you set up the machine. We're going to talk about line speed, foil height. But what we're really looking to do is find that spot where you get no seal, transition into a marginal seal, good seal. You're going to go to a marginal seal then on the top end and get to the point where you then overheat and damage the material as well. Anytime you're setting up an induction sealing application, you're going to want to look at a couple of things. One of the important components is to make sure that your container is running down the center of the induction sealing machine, and more important, the center of the induction sealing head that you're using. So you'll see on all of Enercon's machines that each of the sealing heads, both on the entry and exit, have a decal that says center line. And it's important that your bottle is lined up center there as well. On some of our more advanced machines, we've actually integrated a red LED light which shines down on the center as well, just to aid in operating setting up those machines. You're also going to want to make sure that you have a consistent gap between the top of the closure and the bottom of the sealing head as well. Again, we've got a nice gauge that's used that we send out with every machine. If you don't have these, if you're looking for something like this, feel free to reach out to us, and we're happy to send something your way so you can achieve this setup consistently every time. So how do you find that operating window? What you're going to want to do is set your machine up. Again, make sure that the bottle's centered. You have a consistent gap between your closure and the sealing head. Set your line speed to whatever line speed you're going to run in production, and set the machine. Pick a number. If you want to pick 50% of the output, pick 50. If you want to pick 60, it really doesn't matter. What you want to get to is to find the low end. So if you run your container through and you're finding that you're getting a seal, back it down by 5% and see if you're still getting a seal. If you are, again, back it down by another 5% and see where you just start to get a seal. Then work that range by 1 to 2% outputs on the machine and find that point where you just start to get a seal. That's going to be that minimum point on your good seal range. Now you're going to go to the high end and you're going to say, let me increase this by 5% each time, and start to see that range where you get a good seal until when it starts to overheat. And you're going to see an image here on the left where this is a pretty extreme, where you see a two-piece induction seal with some burning, but you'll see wrinkling. You'll see a number of characteristics. When you get to that point, again, start to back down in 1 to 2% increments, and you're going to find that window where you get a good seal. And again, you're going to find that maximum power level. You're going to see overheating that occurs. Again, it's usually a burning or wrinkling, whatever may happen. So now you found, for example, we've said, okay, your low end was 58%, the high end was 65%. You know this is your range in which you want to seal your container to minimize any leakage that could occur. So what you're going to do is you're going to pick a number. You can pick any number within that range. It's really going to be the number which you're comfortable running and comfortable within the test that you put your package through and is going to give you the most comfort. What we do recommend is that you stay within this range. Some people will say, well, let me push it just a little bit further. What you may do in that process is you may damage that heat seal layer and you may compromise the integrity of the induction seal as well and create leakage problems because of overheating. So now that you have an idea of what materials are involved, how you choose those materials, how you set up the machine, let's talk about some additional considerations that you want to think about when you're packaging liquids for shipping through companies such as Amazon or freight companies such as FedEx or UPS. So some of the pieces that you've got to think about as your package goes through, you may be packaging it in Wisconsin, and you may be shipping it around the Midwest, and maybe your business grows, and now all of a sudden you're shipping it to the West Coast. Well, California is a lot at sea level, Wisconsin's at sea level, but now you're going to be transporting this product either via air or freight, and now you're going to go either over the Rocky Mountains in a truck, where you have very different pressure that package is subjected to, or in a plane in a cargo hold, where you're going to have differences in air pressure. Without an induction seal, that can cause the closure to back off. You can have other pieces which can introduce leakage concerns in there. When you add an induction seal and you properly seal the container, you take that away. Likewise, there's often vibration that's induced into a package. Again, that's something that can cause the closure to back off and possibly cause a leakage on an unsealed container. Again, using induction sealing in that case will eliminate that possibility. Containers can be inverted. Even when a container has a cap applied without an induction seal, sometimes turning that upside down will cause leakage as well. And then you've got to think about, how are you packaging these? Is it a single package? Are you packing, multiple packages within a box or within some sort of transportation method? And then what sort of load is being transferred onto your secondary packaging as well? Are you now stacking multiple cases on top of one another? There are a lot of pieces that come into consideration. By adding an induction seal, picking the proper induction seal, and then setting that operating window, you minimize the chance and set yourself up for success in working with companies in shipping your liquid products.
All right, thank you, Ryan, and thank you, BJ. Let's just take a quick review here before we get to the questions. Some of the things we covered today is to make sure you consult with the packaging experts of each distribution channel, get an understanding of how your packages might be handled differently than how your normal distribution channels handle them, and make sure you're meeting all the requirements. We covered why induction seals are highly effective as part of a double seal strategy, creating that hermetic seal to prevent leaks, provide tamper evidence, and preserve freshness. And how it's important to make sure you select the right liner for both the consumer experience you want as well as the function. In most cases today we're talking about making sure you can prevent leaks. Ryan talked about setting up an operating window and how that's the industry's best practice for ensuring a perfect seal every time. And then again, considering your different distribution channels and how each may require unique packaging requirements.